common multiples. Least common multiples, you have done things like this before, but you have not really dealt with the algebra the same way as we're dealing with it today. So it'll be interesting to see how we do with that. I want to kind of refresh our memories by starting out with some of the more basic type problems. We're going to find the least common multiple of 9 and 12. Now the way that we're going to do this is by finding the prime factorization. We're going to start off with something that you've done before, like I said, factor trees. What two things can I multiply to get to 9? Carpenter? 3 and 3. When you get to a prime number, you circle it. You remember doing this? Yeah. The people who like doing this are the people who know their facts. The people who are like, oh, I hate doing that, are the people who struggle with multiplication. Someone in my last class said that they enjoy this even though they're not very good at multiplication, which I thought was entertaining. So they got a 3 and a 4. 4 is not a prime number. I can actually multiply 2 and 2 to get to 4. Now I'm going to write the primes as exponents. So I'm going to take my first one. I've got 3 times 3, so that gives me 3 squared. So I'm writing it using exponents. And then I'm going to write 12 as primes, which will be 2 squared times 3. I'm just writing it as primes. Now to write the prime factorization, what you're going to do is you're going to use the highest power of each base. Think of it as like promoting it, like moving it on to the next level. So each of my bases have to move on to the next level. So here's my base of 3. Now I've got 2 3s that I can choose from. I could choose this 3 here, or I could choose this 3. But the only one that can get promoted is the one with the highest exponent. So this one moves on, but this one stays behind. So I'm going to move this one to the prime factorization, 3 squared. The other one stays behind. I have to do the same thing with the 2. There's only one 2, so it's the only one that gets to move on to the next level. So that's the prime factorization. Now, in order to find the least common multiple, all I have to do is multiply those factors. So in your calculator, or not, 3 squared, what is 3 squared? 9. And then 2 squared is 4. So what's 9 times 4?
36.
So your least common multiple is just 36. Let's look at another example there. Let's look at 4 and 10. Same idea. Start with your tree. 2 and 2. Those are prime numbers. Factors of 10 are going to be 2 and 5. So I write the primes as exponents. That'll be 2 squared, and then I've got 2 times the 5. Now for the prime factorization. Yes.
So the prime numbers like numbers that can't be reduced.
Yeah, prime numbers are numbers whose only factors are 1 in itself. So like the only things I can multiply together to get 2 are 1 and 2. The only thing I can multiply together to get 5 is like 1 and 5. Yeah. So I have to move a 2 on. I can move either 2 squared or 2. Have to move the one with the highest exponent, so I move 2 square on to my prime factorization. So that one got left behind, and now I have to include a 5, and there's nothing to compare it to, so I just move on my 5. Then, to find my least common multiple, 2 squared gives me 4. 4 times 5 is 20. Let's try one on your own before we get to the ones with variables in them. Find the LCM using prime factorization of 10 and 8. All right, so you had a chance to do that one on your own. You had to find the LCM of 10 and 8. What can 10 get broken down into? Natalia? 2 and 5. Does it matter if I put the 2 or the 5 first?
No.
No, the commutative property of multiplication means that the order doesn't matter. Those are both prime numbers, so I circle my prime numbers. And then I've got 8 and 4, 8. So what can I break 8 into? Tommy? 2 times 4, or 4 times 2, doesn't really make a difference there. I'm going to multiply 2 and 4. Now 4 is not a prime number. What can I break 4 into? Alexis? Yeah. And those are going to be prime numbers, so I circle those. Now I write my number as primes, and if I write that as primes, this will be 2 times 5. 10 is 2 times 5. 8, I can write that as 2 to the 1, 2, 3 power. So it's 2 to the 3rd power. Now the prime factorization, I have to move one of my 2's on. I can move either my 2 or my 2 to the 3rd power. I move the one at the highest exponent, so that one moves on. And then my 5 also moves on. So then my least common multiple, I'm going to multiply 2 to the 3rd power times 5. If you're wondering how to put those exponents into your calculator, you can do 2 and then raised. I'm trying to get to where you can see it on the screen. 2 raised to the 3rd power, then multiply that times 5, and gives you your answer 40. So your LCM is 40, your least common multiple. Yes, sir?
If both of the numbers are 4 hours, like 6 and 8.
Yeah. You could. Yeah, that's a good strategy. That's a very good strategy. Yeah, you can stay on that page. Here's what I would like you to do. You have done what we've done already. You've done that in the past. You have not done this. So what I want you to do is I want you to make a prediction. Knowing what you know, I would like for you to write the least common multiple of those two numbers, 4a squared and 10ab. I will give you about 30 seconds to do that. You're just making a prediction. All right, let's look at the prime factorization and see how you fared. First thing I'm going to do is I'm going to take the numbers just like I did before. I've got 4 and I got 10, and I'm going to make my factor trees. 4 breaks down to 2 and 2. Those are primes, so I write that as a product of primes. Then I take my 10 and I do 2 and 5, also both prime numbers. So I do 2 and 5. Then I do the prime factorization exactly like I did before. I've got 2 squared and I've got 2. Only one of them can move on. I move on 2 squared. And I got to move on to 5. 2 squared gives me 4. 4 times 5 gives me 20. So my LCM of just the numbers is 20. The problem is the letters. Turns out that you use the letters exactly like we did here. We only move on the one with the highest exponent. So here I've got an A, so I've got A squared and I got an A. I only move on the one with the highest exponent. So my A squared moves on, but my regular A stays behind. I also have a B right here, so my B moves on. And there's your answer. Anybody get that? Nice. Nice. Now that you have been shown how to do it, find the LCM of these two numbers. All right, we do this the exact same way we did the problem before. We'll take the 12 and the 8. What can my 12 get broken down? Ryan?
12.
Yeah.
6.
Yeah, I can break that into 6 and 2. 2 is a prime number, 6 is not. I can do 2 and 3 to get 6. So now if I wrote that as a product of primes, 2 times 2 times 3. Same way with the 8, I could do 2 and 4. 2 is a prime, 4 is not. So that gives me 2 to the third power. Now what I've always found is the most difficult part for people is which of these kind of, what do you include in your prime factorization? If you think of it as your base, and every one of these big numbers has to be included, but only one of them, then you have to kind of choose which one you're going to take. And you always take the one with the highest exponent. That's usually the hardest part for people. And then we multiply that times 3. So 2 to the third times 3. If you're putting that in your calculator, that would be 2 raised to the third power times 3. Gives you 24. And what letters are you going to include in your least common multiple? Scout?
We're going to include the B to the fourth power, the C to the third power, and A.
Because we only include one of each. We've got B squared, and we've got B to the fourth, so we're going to include the one with the highest exponent. We've got a C to the third, and we've got a C. C to the third has a higher exponent. And over here we have an A, and we don't have one here, so that A gets included. Now what I'll tell you is that typically when you write your answers, your number goes first, and then your letters go alphabetically. So you have a B, a C, and an A. So typically, what you'll do is you'll include those alphabetically. Now we know the commutative property of multiplication says that the order doesn't matter. It's just writing things neatly and cleanly. Typically what we'll do is we'll write them in order. And these are also written in order. It's just that there's no A here, so they didn't include an A. But both of those are the answer. All right, so I'm actually doing something here. There's two different problems. If you're somebody who at this point in the game are saying, I get this and I'm ready to move on to the next thing, I want you to do problem number 6. If you're one of those people saying, I'm a little bit shaky on exactly what's going on, I want you to do problem number 7. We're going to go over both of them, so if you want to do both of them, you can. But what I want to do is kind of give you an opportunity to kind of choose your own destiny here. All right, so you had your choice kind of to choose your own path here. I want to go over both because some people did both. Some people chose to do the one with the 3 numbers. Some people chose to do the one with the 2 numbers. Let's look first at this one where we've got a 10, a 20, and a 28. Finding the prime factorization of those. 10, I can break that into 2 and 5, both prime numbers. 20, I could do 4 and 5. 5 is a prime number, 4 is not, so that's 2 and 2. So this would be 2 and a 5. This would be 2 squared times 5. What could I break 28 into? Emily? Can I do 2 and 14? I just have more room on this side. What could I break 14 into? 7 and 2. So this will give me 2 squared times 7. So now I have to include the highest exponent of each. So I've got 2, 5, 2 squared. So 2 squared is going to move on to my prime factorization. I need a 5 in there. Well, my 5s are tied, so it's just a 5 that moves on. And then I also have to include a 7. So in my calculator, I'll do 2 squared times 5 times 7, which gives me 140. And now I've got BA, BA, BA. Well, they're all tied, so my final answer is just BA. This one, they actually didn't write them alphabetically, but we left them the same as the way that they showed up in the problem. For number 7, it's a similar type problem. I've got 25 and 25. So I break that into 5 and 5. Break that one into 5 and 5. So that gives me 5 squared. That one gives me 5 squared. I can only include 1, so I include 5 squared in my answer. So 25 is my prime factorization. And I have to look at my exponents. I've got x squared and I got y. So they both get included into my answer.